If you've ever wanted to monitor things around your home or property without relying on Wi-Fi everywhere, this is where it starts, the gateway. This is what receives LoRa data from remote sensors, connects to your Wi-Fi, and then sends that data into Home Assistant using MQTT. In this video, I'm going to set up a LoRa gateway using the Heltec WiFi V4, flash the code, connect it to Home Assistant, and then test it using a simple LoRa sensor node. Once this is working, it becomes the backbone for all kinds of projects, like a weather sensor or a water tank sensor, all running on the same network. This setup is not LoRaWAN. I'm just making a simple private LoRa network for my own sensors around the house and property. The basic idea is pretty simple. The sensor wakes up, takes a reading, sends a small packet over LoRa, and then waits for a reply from the gateway. The gateway receives that packet, checks that the sensor is allowed to talk to it, sends back an acknowledgement, and then publishes the data to MQTT so Home Assistant can use it. So instead of each sensor needing Wi-Fi, each sensor only needs LoRa, and the gateway becomes the bridge between the outdoor sensors and Home Assistant. For the gateway, I'm using the Heltec V4. This board is handy because it already has the ESP32, the SX1262 LoRa radio, USB-C, Wi-Fi, and a small OLED display built in. So for this gateway, most of the hardware side is already handled by the board itself. I don't need to wire up a separate LoRa module to an ESP32, which makes this a lot easier to build. I'm also using a larger 915 MHz antenna instead of the small antenna that comes with the board. For testing on the bench, the smaller antenna is fine, but this gateway will eventually need to talk to sensors outside, so I want to give it the best chance of having a reliable signal. Make sure you use the correct frequency for your region. I'm using 915 MHz here in Australia. The radio on this board is the SX1262, which is a good fit for this sort of project because it gives me long-range, low-power communication without needing a full LoRaWAN setup. One thing to note is that the SX1262 is half duplex. That just means it can transmit or receive, but it can't do both at the exact same time. For this project, that's not really an issue. The sensors are only sending small packets every now and then. The gateway receives the packet, then sends a quick acknowledgement back, so it doesn't need to listen and transmit at the exact same moment. If I wanted to handle lots of devices all transmitting constantly, I'd be looking at more serious gateway hardware, but that would also be more expensive and more complicated. For a few DIY sensors, this setup is a good balance. To install the gateway code, you'll need VS Code, the PlatformIO extension, and the gateway code, which I'll put on my website. I'm not going to do a full VS Code setup tutorial in this video, but the important part is that the gateway code is built and uploaded with PlatformIO. The sensor node I'm using for testing is programmed separately in the Arduino IDE. Once you've downloaded the gateway code from my website, open the folder in VS Code. The main file you need to edit is config.h. This is where you put your own Wi-Fi and MQTT settings. Inside config.h, you'll need to update your Wi-Fi name and password, your MQTT server details, and the LoRa settings. For my setup, I'm using 915 MHz, and my network name is set to my LoRa home. The parent code is also important because this is what stops random packets from being accepted as new sensors. So once you download the code, go through this config file first and make sure it matches your own setup. Once the config is updated, plug the Heltec V4 into your computer with a USB data cable. Then in PlatformIO, you can build the project first to make sure there are no errors. After that, click Upload. If the board doesn't upload straight away, you may need to put it into bootloader mode by holding the boot button, tapping reset, and then releasing boot. Once the upload is finished, open the serial monitor. At this point, you should see the gateway boot, connect to Wi-Fi, connect to MQTT, and then start listening for LoRa packets. The OLED screen on the Heltec is useful because it gives you a quick status check without needing to keep the serial monitor open. So once this is mounted somewhere permanently, I can still glance at the screen and see whether the gateway is online and receiving data. For Home Assistant, I'll assume you already have Mosquitto installed and working. The main thing here is that the MQTT username and password in the gateway config need to match the login details you use for Mosquitto. Once the gateway connects, it publishes its own status and state over MQTT. It also uses MQTT discovery, so Home Assistant can automatically create entities for the gateway. That means I can see if the gateway is online, how many packets it has received, how many sensors it knows about, and whether anything is being rejected. To test the gateway, I'm using a XIAO ESP32C6 with a XIAO SX1262 LoRa module. This isn't the final water tank sensor yet. It's just sending some demo tank data so I can prove that the gateway is working. You can use other boards as well, like the ESP32S3 version, but you will need to adjust the code to match the board and pinout. This is just what I had laying around. The test sender is transmitting a packet that looks like this. In this example, the ID is tank_01, the type is tank, and the name is rainwater tank. The data includes a demo water level, pressure reading, and water height. So even though this isn't connected to the final pressure sensor yet, it proves the full path is working. After the gateway receives the packet, it sends an ACK back to the sensor. That ACK tells the sensor that the packet was received successfully. It will also include the next sleep time. In this example, the gateway sends back next_s as 900, which means the sensor can wait around 15 minutes before sending again. This will be useful for the battery-powered sensors later, because the gateway can confirm the data was received, and the sensor doesn't need to stay awake longer than necessary. By default, the gateway does not just accept every new sensor. Pairing is closed during normal use. To add a new sensor, I press the boot button on the Heltec V4, and that opens pairing mode. Then the sensor can send a pairing request. If the network name and pairing code match, the gateway saves that sensor. Once it's paired, the gateway remembers it, so it will still be there after a reboot. After that, the sensor can send normal data packets without needing to be paired every time. If I want to start again, I can hold the boot button for 10 seconds. That clears the saved sensors from the gateway. This is useful while testing, especially if I change sensor IDs or want to reset the whole setup. I probably wouldn't use this very often once everything is installed, but while developing the project, it's a handy feature to have built in. The reason I'm setting the gateway up first is that I don't want to build a separate receiver for every sensor. Each sensor has its own ID and type. So the water tank sensor might be tank_01. A weather sensor might be weather_01. And if I add another tank later, that might be tank_02. They can all use the same gateway. The gateway just needs to know which sensors are paired, and each packet tells the gateway what type of sensor it came from. The sensor code will also be set up so they don't all transmit at the exact same time. For example, even if two sensors are set to report roughly every 15 minutes, they can add a bit of random timing so they are less likely to clash. That should make the network more reliable as I add more devices. At this point, the gateway is doing everything I need it to. The demo data itself isn't really the important part yet. What matters is that the whole communication path is working end to end. Now I have a gateway that can sit inside the house and receive data from different LoRa sensors around the property. So that's the LoRa gateway set up and working. In the next video, I'll start putting this to use with one of the sensors I've been working on. And after that, I'll build a new water tank sensor using the same gateway. I'll put the gateway code and setup notes on my website, including the parts I used and the config values you'll need to change.